With that, I'm very, very excited to welcome John Schulman to the stage. John is one of the co-founders of OpenAI and the creator of ChatGPT. Please welcome John. John, thank you so much for being here.
Pleasure to be here.
So there are a bunch of questions I'd love to ask you about your work at OpenAI. But before we dive into that, can you tell us a little bit about how you got excited about AI in the first place?
I used to read a lot of sci-fi as a kid. I liked Isaac Asimov's books and Werner Vinge.
Yeah.
And I remember picking up The Singularity is Near by Ray Kurzweil at a garage sale once and looking at all the nice scaling plots, like how Moore's Law and all of its variations. Mm-hmm. So. And then I did some projects as an undergrad in doing things with machine learning. Like I worked on transcribing handwriting into LaTeX for some class, and that was exciting to me.
You also did some physics projects, right?
Yeah. Oh yeah, I did an undergrad in physics.
Okay, nice. And so that led you to do a PhD in machine learning, right?
Yeah.
Now, you weren't always working on language models, right? Can you tell us about the kind of work you did in grad school?
Yeah, I started grad school in neuroscience, but then I ended up switching to robotics, to a machine learning group, Peter Abeel's group that worked on robotics. And so I worked a bit with the robots of the time, like there's the PR2, Personal Robot 2, and we were doing things like using it to fold laundry, in a very, very slow and deliberate way, and I was working on tying knots, getting it to tie knots.
I remember that.
As a kind of simulation of doing robot surgery. That was the motivating application, like having suturing with the robot.
Yeah.
So yeah, I worked on robotics a bit for a while, and then halfway through the PhD, switched over to reinforcement learning.
If you look back on your PhD work, I'm curious, which projects do you think stood the test of time the most?
I'd say the work on reinforcement learning and specifically applying it to neural nets, definitely, that was the stuff that then ended up making a difference in the long run. Some of the earlier work on robotics definitely produced some nice demos at the time, but I don't think the methods are that general.
Yeah. Cool. So we all know that OpenAI does great research and builds great products. But OpenAI didn't start out that way, right? It started out purely focused on research, right? Mm-hmm. Can you tell us about that transition? What led to the decision to do both?
Well, we were interested in releasing some kind of product or releasing something to the world from the beginning, but we also didn't want to go too far out of our way to build a product. So there were some ideas being tossed around, but nothing quite came together. And we wanted to raise more money, and it was kind of, even though our structure didn't require us to make money immediately or be profitable, it seemed like we were going to be able to raise more money if we actually had some kind of product out there. And also we felt like it's nice if your research actually connects to the real world instead of just being kind of, I don't know, just having, just being like publishing things and putting together demos.
Yeah. And so your first product was the API product, right? How long, once you guys decided to start building products and shipping that, how long did it take to decide on building an API? Were there other ideas you considered?
Yeah, we had some other ideas. A lot of them were more like domain-specific applications, like doing translation. So after GPT-3, we knew that these models were impressively smart, and there must be something you can do with them. So we ended up thinking about a bunch of natural language processing applications, but at the time we were thinking that the model wasn't quite good enough at anything to be useful by itself, so we would probably need to fine-tune it and build it, make it really good for a specific application. But I think then there was the other, I actually don't think we could have succeeded with one of those products because it would have required building up a ton of domain expertise and really digging into that domain, and it would have been, it would have required a lot of work that's separate from our main research. So the nice thing about an API is it's just basically taking the thing that the research team has built and commercializing it directly, as opposed to going and building this whole other product that's separate from what the research team is doing.
Were you deterred at all by the fact that there were other AI APIs out there? Other companies have tried building AI APIs, but none of them had been a huge success?
A little bit. That was definitely a concern, that there were some other APIs like for object recognition and vision, and I think some of them were moderately well used, but they weren't spectacular products. So we had some concerns about that, and I think in retrospect those concerns were warranted, because I'd say the original model we released the API with wasn't good enough for most people. I mean, it was a pretty small business for a while, and I think it only, the model started to get good enough only in the last year and a half or so.
So it wasn't an overnight success. Mm-hmm. When did you realize that it was going to work out, that the API was, the right choice, or that it was going to work out?
Well, I think you could have looked at the trends and predicted what I just described, that maybe the initial model wasn't good enough, but some future models would be. And like serving models seemed like a generally useful thing to do. So I would say that the API only saw a lot of growth in 2022, just after we had the GPT 3.5 based models coming out, and then we sort of had a pretty steep growth curve. And then ChatGPT itself made the API a lot more popular because a lot more people got excited about language models in general.
Yeah. Now, before we talk about ChatGPT, let's talk about scaling. This is a distributed systems event in some extent. We all know OpenAI uses a huge amount of compute. And actually, I think OpenAI was perhaps the first to really go all in on scaling. Where did that belief in the importance of scaling models and compute come from?
The idea that bigger models are better was a bit in the zeitgeist, that people had produced the best benchmark results with fairly big models. And, but I guess it wasn't, and I would say the founding team of OpenAI was leaned more towards this aesthetic of scale up simple things rather than trying to build some complicated, clever thing. Like, we definitely believed that simple things that are doing the simple thing right was tended to win in machine learning. But I would say for scaling, it's not, scaling looks easy when you see the final result, or it looks obvious when you see the final result that like curve goes up and to the right, but often there's a lot of complexity in getting there, and you have to say, I mean, there's all the systems, just doing the engineering is very difficult to get something that's actually performant at scale, and then there's usually all these little details, like you have to scale your learning rates just right, otherwise you get worse results with big models, and you have to scale your data up along with the model size. So I'd say that it took several years to figure out what were the right recipes for scaling things.
Yeah. Now, we talk about scaling as if it's one thing, but there are many different dimensions you could scale, right? The amount of data, size of the model, just the amount of compute you put into it, maybe other things as well. Is it obvious which ones matter and which ones don't?
Well, it's usually not completely obvious. I mean, model size and data are the two biggest ones, but then you usually have a lot of hyperparameters that have to be scaled properly, and it's you have to do a lot of science to figure out how to scale them.
Yeah. So can you share some intuition about why scaling is hard? Like, why aren't we using much? What's stopping us from using 70 trillion parameter models today, or even bigger?
Yeah, I think a lot of that is about well, it's about compute efficiency. Like so now we know you can train a small model for really long or a big model for short, and there's some trade-off, and it turns out that somewhere in the middle you get the best compute efficiency. So if you put the flops on the x-axis, you have a bunch of curves of, you draw your learning curves of loss versus flops. There's some optimal model size for getting the best performance. So I think what we have now is just using transformers and using the training recipe we have, it turns out certain model sizes are the most efficient given the amount of compute resources we're putting into it. But that's probably going to change as we start putting more compute into the training runs, and also maybe as we start to change the training methodologies and the types of data we use, we also might find that different size models end up working the best.
Do you have a sense of whether this is something with diminishing returns or not, like how far this will take us?
Yeah, I'd say often the returns diminish as you scale the current thing, but then there are other innovations that let you continue. So I guess I don't see deep learning in general reaching a plateau or anything, or hitting diminishing returns. Maybe just doing the most basic thing reaches some diminishing returns.
Yeah, makes sense. Since this is Ray Summit, let's talk a little bit about distributed systems and infrastructure. So I'm sure almost no one in this audience knows this, but early on, or maybe partway through your PhD, you actually built your own deep learning framework called Computation Graph Toolkit. Can you share a little bit about why you built that and what you were trying to achieve?
Yeah, some people might remember Theano. That was this.
Absolutely.
That was the AutoDiff framework from before TensorFlow and PyTorch. So Theano was amazing, but it also was starting to hit its limitations. Like it would sometimes take half an hour to compile your graph before you could do a single step. So, and I wanted to do some things like with recurrent networks, and Theano wasn't that great for it. So I ended up working on building one of these things. And actually, I think it was a great learning experience. I mean, it turned out that Google, there was TensorFlow and PyTorch right after that, and those ended up.
I think you were working on CGT. This was 2015 in the fall, and then TensorFlow came out right after that.
Yeah, I started working on it before I knew about TensorFlow, and then I found out about it, and maybe part of me was disappointed that I was getting upstaged by Google, but it's fine. Yeah, I think everyone should write their own AutoDiff. Everyone should at least write their own little AutoDiff library at one point to get a really good intuition for backprop.
It's a great idea. Yeah. But this is all, the slow compile times for recurrent neural networks. This is, I had forgotten about that. That was a long time ago. But if I remember correctly, it was quite fast. It was actually, quite well architected. And you actually were an early Ray user, or maybe you attempted to use Ray. You used Ray quite a long time ago, before it was really ready. Can you share, do you remember what you were trying it for and what your experience was like?
Yeah, this was back in 2016, 2017, when you guys were just getting started on it. Yeah. And at the time, I was doing something in the realm of architecture search. And I remember creating some issues on GitHub about the scheduler not doing the right thing, which you guys have fixed since then. But
it's come a long way. There's still GitHub issues, so probably.
You closed that issue at some point, so I remember seeing a
so it must have gotten
notification
fixed.
about it. Yeah.
Nice. Can you share a little bit about, you guys are pushing the limits at OpenAI of scale in a lot of different dimensions, and so you may encounter challenges that a lot of other people don't encounter. Can you share a little bit about, what makes infrastructure hard for the kind of AI work you guys do at OpenAI?
Yeah, we have a library for doing distributed training, and it does model parallelism. So you're sending around weights and gradients and activations, and yeah, Ray, and we use Ray as a big part of that for doing all the communication. And it's it's been very useful having this solid component that we can build on. We've had various. I mean, OpenAI has a lot of the type of people who like writing their own distributed systems code.
Yes,
so
familiar.
we've had our own. Everyone likes writing their own thing. We've had our own internal libraries. Often when you develop something internally, it works great for the person who wrote it, but that person usually doesn't want to maintain it for years, and it's not very well documented or general. So we've had our own like internal systems, but then I'd say it's been nice switching over to Ray, so we have this solid component that is very well documented and supported that we can build on. Yeah.
So if you weren't using Ray, what would you be using?
Yeah, we'd probably we'd probably roll our own thing and use tools. We'd use the other lower level tools out there like Redis and MPI and so forth, and just glue those together.
Yeah, lots of MPI, lots of Redis.
Yeah.
Makes sense. Nice. So tell us about ChatGPT. How did you get the idea? When did you start working on it?
Yeah, so I'd say it started off, I personally was working on a project called WebGPT before this, which is like a question answering system that does retrieval, and so it'll you ask a question and then it'll go and find a bunch of relevant sources by doing a web search and browsing some of the pages it finds, and then write a 1 or 2 paragraph answer with citations. And this was what we were trying to get at with that project, was getting language models to use tools, and like we were trying to work on this problem of truthfulness. Like, how can you get models that don't make stuff up? They just say things that are true and based on.
Has that one been solved?
I'd say we made progress on it. It's not completely solved, but yeah, we've come a long way. So yeah, we were really interested in truthfulness. So that project, we had worked on this project and we had published a paper about it, and we're trying to figure out what was the next version of it. And for question answering, I'd say chat starts to make a lot of sense, because you need to do things like follow-up questions and clarifying questions. And and there were some internal, we had been playing with chat internally a bit, like at OpenAI, and it seemed like the models were quite good at it. So yeah, we decided to have a dialogue-based system for the next iteration of our system. So we started collecting data in like early 2022 that was like specific for chat. We were originally, it was going to be a successor to this WebGPT system, and eventually we really ended up liking the chat models, and the whole retrieval part ended up being a little complicated, so we temporarily dropped that, and we just decided to focus on the chat models. And I'd say we were surprised by how good the models were. Or how useful they were. So we had an internal demo, and I definitely used the demo a lot for coding help, because the models are really good at answering questions about code, especially when you're trying to use new libraries. So yeah, it became, we started to think that it was a good idea to release, to like do a public release and just let other people try out the model. And that ended up getting delayed a bit, because we had GPT-4 finished training, and everyone got excited about that model. And the chat model we had trained that was based on GPT 3.5 was that kind of got sidelined for a while. But anyway, we ended up deciding to do a release anyway, and worked with the product team who put together the UI and everything for it, and then ended up launching it late in November that year.
It was a great decision.
Yeah, it turned out.
Were you surprised by just the world's reaction to ChatGPT, or, given that you had a lot of experience using it internally, did you kind of see that coming?
Yeah, we were very surprised. I mean, we did have beta testers, so we had friends and family using it for a few months beforehand, and there were definitely some enthusiastic users, especially people using it for code, but it didn't really, I don't know, people weren't that excited about it, and not everyone ended up, not all of the users ended up coming back to it a lot. So only a few of the people who we gave access ended up using it regularly. So I think what happened was when everyone got access, people sort of taught each other how to use it and what use cases ended up working. So it was kind of the social aspect of it was pretty important. Like people teach each other how to prompt it and what kind of tasks it's good at. So I think it really, just the fact that it was really easy to use and people could share their use cases with each other caused this mass excitement.
Yeah. So you mentioned using it for help coding. What about today? What do you use ChatGPT for today?
I'd say that's still my biggest use case personally. I also just use it here and there as just to ask questions. If I have random questions about history or science or whatever, I'll just ask it. But I'd say the one I get the most utility out of is coding.
Yeah. So you've been in AI for quite a long time. If you look back on your time in AI, more than a decade, what do you think of as the biggest advances or conceptual breakthroughs that have happened during that period?
Well, yeah, I guess I started grad school in 2010, so that's when I was sort of seriously in the field. And I'd say back then, deep learning hadn't really taken off.
Yeah.
So it wasn't even clear. I remember thinking that it wasn't clear what you would use neural nets for. Like if it wasn't clear that making the model that we would even know what to do. If we had a model that had like a model that was more powerful, it wasn't even clear exactly what we would do with it. So I would say there were a lot of things that were less obvious then. Like we didn't know deep learning worked really well. We didn't know exactly what training objective you would use. If we did know that neural nets could be trained, it wasn't clear exactly what to do with them. And so I guess the answer there ended up being fairly simple. Like whatever, you can do reinforcement learning with neural nets. You can train classifiers. You can do maximum likelihood on sequences. And all these things work pretty well. I mean, some things that were popular back then didn't end up working that well or didn't scale as well. So yeah, it's kind of the set of things that ended up scaling wasn't easily foreseeable at that time, but yeah.
And certainly the importance of scaling.
Oh yeah, and definitely scaling, yeah. The fact that scaling was so important and the whole paradigm of scaling laws.
Yeah.
Yeah.
I'm sure you probably took an introductory machine learning class at some point, right? And at least, I don't know about now, but a decade ago when they were teaching introductory machine learning courses, the course would often start by framing different areas of machine learning. They say there's supervised learning, which is like classification and regression, and there's unsupervised learning. And when we talked about unsupervised learning, at least when I took machine learning, it was mostly about clustering, like k-means clustering and things like that. I feel like, I'm curious if you would agree that our perspective on unsupervised learning has changed quite a bit over the past decade.
Oh yeah, definitely. I mean, now it's not even clear what unsupervised learning means. Sequence modeling is like the way the language models are trained. Is that unsupervised learning? It's kind of supervised by predicting the future given the past.
It still fits into the regression framework, or classification framework, but you don't have to spend a lot of energy labeling data and things like that.
Yeah.
But yeah, it's not k-means clustering, that's for sure.
I mean, you can say that supervised learning is a special case of unsupervised learning, or doing maximum likelihood.
So I think, looking back a decade ago, problems like unsupervised learning were not that well understood, or perhaps we didn't know how to conceptualize the problem. What do you think are the problems today that we're still figuring out how to formulate?
I'd say there's a lot of problems around, well, I'd say one problem I ended up thinking about a lot is data quality and like how to get really good supervision so like GPT-4 is really good at a lot of things, and it has a lot of breadth of knowledge, and it's often hard to even collect good labels to make it better. Like if you, like people ask it questions about, they ask about all sorts of obscure topics or very technical topics, and it's hard to find people who can label this, who can provide good labels. So there's this problem of how do you supervise a model that's kind of superhuman, and I would say sometimes this is called scalable oversight or scalable supervision. People first got interested in this from the standpoint of alignment and how do you make concerned with like the very smart models, and how do we make sure they're doing doing what humans want. So I'd say in this area, like some of the problems haven't even been formulated precisely yet.
Yeah. So you have good taste in problems and what to work on. How do you decide what problems to work on?
Yeah, I don't think I have a really general framework for doing this. I try to think about some real-world use cases, and what are some common limitations of our existing methods that would unlock a lot of opportunities. And I try to think of the advances that would feed into a lot of that would have a lot of downstream implications.
And are you thinking about how we get to human level intelligence and kind of working backwards from there, or thinking more about products that could be built or applications?
I'd say I do a little bit of all of those. I mean, I'm thinking about what humans can do and how the human mind works, and like trying to introspect is useful, but it can also be misleading. So I think it's useful to think about where are humans much better than our models, and where we might be missing something. But it also, it's hard to predict what order we're going to get AI to solve different problems. Yeah. And if something is, how hard something is for humans doesn't necessarily correlate that well with how hard it is for AI. So
math is hard for both of us.
Right, definitely. Yeah, so that's one.
Yeah.
Yeah.
So when you think about the path to, say, human level intelligence, do you think of it as more of a research challenge, an engineering challenge, both, or does the distinction not make sense?
Yeah, I'd say it's both. It's a little of both, and the boundary is a little bit blurry. Like, definitely, you need to do a lot of engineering to get more data and train bigger models on that data, and then there's a lot of research for like how you can to just make that scaling work. You need to figure out the recipe of how all your hyperparameters scale, and then there's open questions about things like data quality and supervision that I just mentioned.
And you mentioned high quality data. In your view, when a human is learning, right, how much high quality data do we have access to, like in a normal educational experience? Like how much do, like when humans are learning, like learning from their parents or schools and so forth? Like yeah, I mean, we have access to tons of data, right? Both things like textbooks as well as just all the, sensory input that we get in. Mm-hmm. Do you consider some of that high quality and some of that low quality? Oh yeah,
well, I guess human learning, humans are extremely, I guess humans are able to learn from very undiverse data. So I think one of the most remarkable things is that a human can grow up in like spending most of their time in one household and talking to a small number of people, maybe going to school. So there's not a lot of data diversity compared to what we train our systems, deep learning systems with, but still you get an extremely robust model, like a extremely robust vision system, even though you've only seen this one house. So that's pretty crazy, and I think we're nowhere near.
There are limits to that, though, right? If you
Right.
if you never see vertical lines or something like that,
Yeah.
This has been fascinating. Are there any common misconceptions that people have about OpenAI that you'd like to clarify for us?
Yeah, I'd say sometimes I read Twitter and people are talking about ChatGPT and they have some speculations about what we're doing, and sometimes I think, sometimes people have some, people often think we're doing a lot more than we're actually doing. Like they think we're monitoring everything, like monitoring Twitter and usage in real time and fixing the model, like fine-tuning all the time and fixing all these problems. And yeah, I'd love to do
like the jailbreaks.
Oh yeah, fixing jailbreaks and like finding when the model gets a riddle wrong, and we're going to go and fix that. So yeah, it's more like we love to fix things faster, but it's often hard. Like you can't, you don't want to just play whack-a-mole and fix these little problems. I'd rather like look at the bulk of use cases and make everyone's experience better. So it's more like when we get feedback from people, like they give thumbs down, we use that as part of our data labeling effort, and we try to collect some labels to fix those examples. But yeah, I'd say that's, yeah, people also, yeah, people think we're doing all sorts of crazy things that we're not doing. But.
Glad to hear it. Yeah. John, it's been a pleasure. Thank you so much for being here. Really enjoyed the conversation. Everyone, please join me in thanking John Schulman.
I guess I will. Thanks for having me.
Yeah.